Question 20. Prove algebraically that the difference between the squares of any two consecutive integers is equal to the sum of those two integers. First, if we have an integer n, then the next integer is n plus 1. They're consecutive. Let's construct this. First, we need the squares of the two consecutive integers. That's n squared and n plus 1 squared. We need to find the difference of those, so that's one subtract the other. The largest subtract the smallest, and since this is the next one, it's bigger than the first one. So n plus 1 all squared make n squared. Now let's expand this and see what we get. So n plus 1 all squared is the same as n plus 1 times n plus 1. So n times n is n squared, n times 1 is n, 1 times n is n, and 1 times 1 is 1. These two cancel out, n squared take away n squared, and we have 2n plus 1. Now let's see and check that it's equal to the sum of the two integers. We have our two integers there, n and n plus 1, and if we add those two together, we get 2n plus 1. So we've proved that the difference between the two squares, this calculation, is equal to the sum of the integers, this one.